Hey guys, welcome to this video. We're looking at chapter 4, simultaneous equations, but also in the graphing context. So we're going to kick off with just graphical solutions of simultaneous linear equations. We're all familiar with y equals mx plus c as our format for our straight line graph, m being your gradient, c being your y-intercept or the constant. Now, if we had as two examples, so x is equal to 2y, let's make that x plus 2y is equal to 4, and y is equal to 2x minus 3. Now, if you were to graph that, we could always rephrase that to, we're going to move the x across to this side. So we got 2y is equal to minus x plus 4, but this 2 needs to disappear. So we're going to halve both sides. So we'll end up having minus x over 2 plus 2 as our equation. The bottom equation here will remain y equals 2x minus 3, where 2 is your gradient, minus 3 is your y-intercept, and this is the gradient is negative a half, and your y-intercept is 2. So if we were to graph this, you end up having something like, so your positive graph, so the blue one is going to be something like that. Actually, that's not really to scale. So if this is a minus 3, if we solve for the x-intercept, you'll have your y-intercept is equal to 3 over 2 or 1.5. So 1.5 is over there, and we'll have the graph looking like that. Okay, with the green one, we'll have the y-intercept at positive 2, so maybe about there, and because it's a negative half, it's less than 1, so not only is it going down, but it is more of a shallower slant. The x-intercept, okay, so x-intercept is when y equals 0, so the x-intercept is at 4, so we could say that 4 is about here, okay, and this is going to be our other graph. Okay, so what we've done, essentially, compared to the previous chapter, we are just sketching two linear graphs, but the whole idea of this chapter is we're wanting to work out simultaneous ones, and so that is our point of intersection. Okay, so point of intersection, and we'll work out how to solve that. Now, graphically, if you had everything to scale, we'll be able to assess through this. This is going to be 2 and 1. Okay. So what we could also say that 2 and 1 is the solution for this pair of linear equations. I'm going to move on to a different example just to help you just understand how this works. So let's say we have 3x minus 2y is equal to 19. 19, and then we have 4y plus x is equal to minus 3. I'd like you to check if 5 minus 2 is a solution. Okay, so we're wanting to check that this is a solution. So we've got two lines here, and they're going to cross over each other, and we're wanting to know if 5 minus 2 is the point of intersection where they cross over. So what we need to do is basically substitute these values for x and y into each of the equations and see if it holds true. So let's put 5, so we'll start with number 1. So we've got 3 times 5 minus 2 times minus 2 is equal to 19. Does that equal 19? So minus 2 times minus 2 is positive 4. 3 times 5 is 15. And so 19 does equal 19. So that means that this line does cross over that particular point. We need to know if the other line does the same. So we've got 4 times minus 2 plus 5 is equal to minus 3. So all we're doing is substituting these values for x and y. 4 times minus 2 is minus 8, plus 5 does equal minus 3. Okay, so that is also a solution because both of them hold true. Then that is a point of intersection. Yes, it is a solution. Okay, both lines do go through that particular set of coordinates, and if they both go through that particular set of coordinates, they must cross over at that particular point in time. All right, so the next video we're looking at solving simultaneous equations through substitution and elimination. This is just more a graphical thing. Provided that you are sketching the graph to scale, you'd be able to accurately find where they do cross over visually. Okay, if you have any questions, let me know. Otherwise, see you in the next one.